Sergi. Oh,
Perfect.
or the Reverend Sergi as it says in the biography, though.
Anyway,
Yes.
we have one announcement to make. That is that the social engineering panel will also be simulcast down in the movie area on the second floor. It can get a little crowded, so if you want to go down there and check it out in air-conditioned splendor, feel free. It's already smelling a little bad with the crowd over there, seeing Jello now, so use your better judgment. And without further ado, I'll turn it over to Gonzo.
Well, thanks for the applause. I see the checks got to everyone. So, has everyone been having a good time so far? That's it? Don't scream that loud, man. To bring feds in here. What's the matter with you? So, let's talk some technology. Non-lethal technology. What I'm going to do is talk about electromagnetic pulse bombs. I'm sure that's going to bring the DoD guys in here too. It's similar to, I guess, for those of us who've seen The Matrix when they had the squiggles and they had to shoot that pulse off to kill it. It's similar to that in some ways, but I'll go into the whole military applications of it and what Big Brother has done with it. So the effects of it, well, it was first noted, it was in World War II during some high-altitude nuclear weapons testing. And it was marked, it was a short, well, it was hundreds of nanoseconds. And it was an intense electromagnetic pulse burst that'll radiate out from a point of an impact, getting weaker and weaker as it goes out. And, well, it's strongest around point of impact. But what it'll do is it'll make varying fields of voltage, kilovolts, on anything that's exposed electrically, copper wiring, railway signals, even some parts of automobiles are subject to it. So what makes it so important for the military to use is that in the end you can fry just about any type of electrical equipment that you want, radios, anything. And given how it's, the strength of the electromagnetic pulse and its durability of equipment, you can end up like literally losing just about everything for whatever you've got going with it. The damage itself is similar to actually of a lightning strike, and I've got a transparency I'll show everyone. It shows what a spike is like when it hits. So some commercial computer equipment is especially at risk because of the amount of the metal oxide semiconductors in it, or MOS devices. And because you don't really need a lot of energy to destroy them, and they're cheaper to use in mass quantities. So that really puts us all at risk for it. And what it'll happen is it causes a gate breakdown, and that's what it causes, like when there's any excess of tens of voltage, and it'll actually cause physical hardware to break down. That's the gate breakdown. And if it's not strong enough to cause any thermal damage, the power supplies in the equipment will still create enough energy to further that pulse, and you're still going to get fried from it anyway. So when the damaged equipment can still be reliable, the shielding of the equipment still doesn't provide a full defense because any cables or exposed copper wiring is going to act as an antenna, and it'll fuel any electromagnetic pulse into it. It'll take whatever you've got out. Let's see, so the technological base for it, there's a lot to it. Most of it went over my head, because I'm not into science and math. That's why I majored in English, so I wouldn't have to figure out half of this. But it's been around for a while, and the important stuff in this area, it's explosively pumped flux compression generators, not to be confused with a flux capacitor, by the way, propellant or any explosive magnetic, hydrodynamic, or MHD generators, and a range of the HPM devices. The one that's leading in that area is a virtual cathode oscillator, or more commonly known as a Vercator. And there's a number of experimental designs that have been tested on it, and there's a lot of work that shows about it. You can just do a Google on it, and it'll come up. So what it looks like, when I mentioned that transparency before. If everyone, all right, can you all see that all right? All right, so the colors show the spike on it. On the nuclear EMP, the transient is the red one. The green one, as I mentioned about the lightning strike, right here going down. And the flux compression generator, purple one, it goes up and it'll just drop. All right, so let's talk about the explosively pumped compression generators. All right, it's old technology related to the bomb designs. The first one actually was shown by Clarence Fowler at Los Alamos National Labs in the late 50s. And since that time, there have been a number of designs that have been built, tested here. Russia's got them, a number of other countries as well. And what it'll do is it'll produce electrical energy. It's a number of megajoules and tens of hundreds of microseconds in a tight compressed shot. And no, I don't know how much a megajoule is, but from what I understand, it's up there. The power levels are actually measured in terawatts to tens of terawatts. And the FCGs can be used directly or as a one-shot pulse power from microwave tubes. So to give an idea of how strong it is, power produced by a large FCG is anywhere between 10 to 1,000 times greater than a lightning strike. So the idea behind it is to use a fast explosive quickly to compress magnetic fields. And it takes a lot of the energy from the explosive into that field. The initial field in it, before the explosion, is produced by a start charge. And that works because it's made available by an external source, a high voltage capacitor bank, or a Marks bank, a smaller FCG or an MHD device. In theory, any device that can create current in tens of kiloamps to megaamps will be proper for the use. A variety of different patterns are available, but the most common of them are coax CFGs. And it stands out because it's basic cylindrical, and it leads itself for munitions packing. So let's talk about the explosively pumped coax generator. A typical generator like that, it's a copper tube, and it's the armature. It's filled with a fast, high-order explosive, such as B and C types, for you poor man James Bond fans there, to blocks of PBX 9501. And the armature itself is surrounded by a helical coil, usually copper, and that makes the FCG stator. And the stator's winding, in some designs, is actually segmented with other wires, bifurcating the ends of the segments to best use the inductance on the coil. So the strong forces made during that operation could theoretically disintegrate the device, if not cut off quickly. So, and it's usually done by adding some kind of jacket of something that's non-magnetic, and the materials like fiberglass or concrete in a matrix of epoxy will take care of that. In theory, it's like any proper mechanical or electrical properties can be used in areas where weight is an issue, such as a missile warhead or an air-delivered bomb. Kevlar or glass epoxy composite could be used as well. It's typical that the explosive is going to detonate when the current peaks. And it's usually done with an explosive lens plane wave generator, which makes a uniform plane wave burn or detonation in front of the explosive. After that, the wave of the explosion itself will spread through the coil, actually forcing it into a conical shape anywhere between 12 to 14 degrees of arc, where the armature is going to be expanded to the full diameter of the coil itself, making a short circuit between the ends of the coil, shorting and isolating the start current source, and trapping the current within the hardware itself. The spreading short has the effect, it'll tighten the magnetic field and reduce the inductance of the coil. So such generators like that, it'll make a ramping current pulse, which will peak before disintegration. And there's other results that show like the ramp times and where it peaks and where it'll drop and all that. The ratio of the output current itself, it's gained according to design, and there is variance in it depending on who makes it. Numbers as high as 60 have been seen. And in other applications where weight and space are concerned, the smallest obviously is going to be the best. And the applications can exploit a cascading of the FCGs, whereas the primer, it'll actually be the start current. And it's been backed up with experiments done at various national labs, Los Alamos being one of them. So the main concerns in adjusting anything like in that for weapons application lies actually in the packaging, because the start current supply matching to the unit of extended load. And connecting to a load is simply, it's just the coax geometry and the conical designs. More importantly, it's available for weapons where FCGs can be stacked axially with devices such as a microwave Vercator. And the needs of the load, such as that, in terms of timing and waveform shape, can take care of inserting transformers, pulse shaping networks, and other explosive high current switches. So now to drive that, you need some kind of explosive. So the design for that, it's an explosive-driven magneto-hydrodynamic. It's a younger form of the FCG. Technical issues like the weights in the sight, the size of it, again, are a concern. But it seems to be that the MHD devices themselves only play a small role into where this is going to go in the future. And the main principle behind it is that, that a conductor moving through a magnetic field will make an electrical current opposite the direction of the field of the conductor motion. So in a propellant or explosive-driven device like that, the conductor is plasma of ionized propellant gas, and it'll force it through the magnetical field, and the current is gathered by the electrodes, which are in contact with that plasma stream. And the properties of it are best used when you seat the propellant with a proper additive that'll ionize during the burn. So experiments have been done that shows a number of propellant gases used in conventional ammunition propellant as a base. Cartridges of such propellant can be loaded like regular artillery rounds for multiple shots. So for a tactical setting, draw your own conclusions. The Vercator itself has some of the FCGs that are a potent technology base, because obviously for it being so strong, and the output of itself, of its base physics, is restricted to frequencies below 1 megahertz. So many targets are going to be difficult to hit, even with a high power at such frequencies. So aiming the energy from that, it's going to be a problem. But the high power device itself will take care of both of the problems, because the output power can be tightly condensed, and it'll have a better ability to take on both energy into the targets. So, and there's a number of these that exist. Again, do a Google, you'll see it. Slow wave devices, magnetrons, relativistic klystrons are some of the names for them. And the Vercator itself is interesting because it's only a one-shot unit, but it'll produce that very strong, powerful single pulse. But mechanically, it's very compact, so you can do all kinds of applications with it. And it can function over a number of microwave frequencies as well. So the physics behind that itself, it's a lot more complex. But basically, the Vercator itself, you're speeding current through an electron beam against a mesh of some kind of foil anode. And the electrons will pass through the anode, making a bubble space, and it'll put the charge behind the current. So you'll get a lot of the electrons that actually pass through it, and under the right conditions, it'll actually make it oscillate at the said microwave frequencies. So the space itself is put into a resonant cavity, which it's properly tuned, very high peak powers can be made. And regular microwave engineering techniques have been shown that it does work. And as an aside to it too, it's, well, that's not relevant. That's too complex for this, no, at least in this setting. But it'll go into like the power levels. It'll range from 170 kilowatts to over 40 gigawatts over numerous frequencies of decimetric and the centimetric bands. Two most common configurations of the Vercator and the axial Vercator. I'll call them the AV and the TV. The AV, in its simplest, it's cylindrical. It's a waveguide structure. And the power is extracted by changing the waveguide to a conical horn, which will function as the antenna. And the AVs usually oscillate in a transverse magnetic, or TM, mode. And the transverse Vercator will inject a cathode current from the side of the cavity, and it'll oscillate in the transverse electric mode. So the concerns with that, it's that the design, it's output during pulse duration, which is usually of the order in a microsecond. And it's restricted by the anode itself actually melting. The stability of the frequency that it'll oscillate at, and that's compromised by the cavity mode hopping, conversion efficiently, and the power output. Now, the power efficiency from it, it's appropriate for a selected antenna type, and it can be a concern given the high power levels and the potential for electric breakdown in insulators. So the lethality of it, it's pretty complex. Unlike a regular technological base for weapon construction, which, for more reference on that, there's a number of publicly made documents for it. The lethality, it's been reported much less frequently. And the calculation of the electromagnetic field, it's the strength of it are attainable at certain radii for a target. That's a straightforward job. Determining kill probability for a target isn't always set. So, but there's good reasoning behind this. That's because the targets are varied in their durability, if they're shielded properly, anything like that. And the equipment that's been protected against the attack, it'll take a number of varieties of the magnitude greater field strengths than the standard of commercially rated equipment. So more importantly, various manufacturers issuing of the similar types of equipment can vary a lot in hardness due to the variables in the electrical designs, cabling systems, shielding designs, etc. And the second problem is in figuring out the lethality of the coupling efficiency, which it's a measure of how much power is transferred from the field made by the weapon into the target. So only power coupled into the target can do the damage, or any useful damage. So now when you get the coupling modes and how it actually goes into the targets, there's two principles behind it. There's a front door coupling that'll usually happen when power from an EMP is set off, and it's coupled into the antenna associated with the communications or radar, let's say. And the antenna is designed to couple the power in and out of the equipment, and it provides a good path for the power flow from the weapon, and that's where you get all that damage. Now, backdoor coupling happens when the electromagnetic field from a weapon makes large transient currents, better known as spikes, when made by low frequency or electrical standing waves made by a high power device like that, or a fixed wiring cables providing connections to main power or a telephone network. So equipment connected to anything exposed will experience the transient spikes or standing waves, which can damage the power supplies, and if they're not guarded properly. So a low-frequency weapon, it'll couple well into regular wiring due to the fact that most phone lines, data lines, and all that, building corridors, apartment buildings, because it's all exposed. So in most cases, any particular cable, it'll leave everything open because it's joined at approximate right angles. So whatever the relative familiarization of the weapon's field, more than one linear segment of the cable run itself, it's going to be oriented in such a way that good coupling can be gotten. It's also worth noting the safe operation envelopes of some common types of the semiconductor devices, because the breakdown ratings for silicon, high-frequency bipolar transients, you'll find those most often in your radio transmitters, things like that, will vary between 15 to 65 volts. So the gallium arsenide field effect transistors are usually rated between 10 volts. So the high-density DRAM is essential for many computers, and it's rated to 7 volts. Generic CMOS logic has a rating of between 7 and 15 volts. Microprocessors running off a 3.3 or 5 volt power supply is related close to that voltage. And modern devices or equipment with added circuits to each pin sink, the static discharge, and steady employment of a high voltage will get past that. So communications interfaces, power supplies, that has to meet some kind of standard requirements. And interfaces like that are usually protected by isolation transformers that will have a rating from hundreds of volts to about 2 or 3 kilovolts. So it's obvious that once defense is made available by a transformer, a cable pulse arrestor or shielding is bypassed, voltage as low as 50 volts can do a lot of damage to the equipment. So the high-power magnetic weapons functioning in the centimetric bands and other, well, on the other hand, an additional coupling process to backdoor coupling. And that's the ability to couple directly into the equipment through ventilation holes, space between panels and poorly guarded interfaces. In these situations, anything going into the equipment is going to act like a slot in the microwave cavity, leading more microwave radiation into the center of that cavity. The radiation is going to form a spatial standing wave pattern. The components in the antinodes within the standing wave are openly high electromagnetic fields. Due to the fact that so many microwave weapons can couple easier than low frequency weapons, and in many cases get around safety devices that'll stop devices, made to stop that. The microwave weapons do have the ability to be much more lethal than low frequency weapons. And research has been done in this area. It shows a difficulty in producing a workable model for guessing equipment vulnerability, but it does show a solid model for protecting equipment. The variety of a likely target in the unknown, geometrical layout, and the electrical details of the wiring and cabling infrastructure surrounding it, it makes exact prediction impossible. But there have been formulas drawn up for it. So a basic approach of dealing with it, this is relating to backdoor coupling, is to figure out known lethal voltage levels and then use this to find out the needed field strength to generate the voltage. And once that's figured out, a lethal radius for a given weapon configuration can be made. So, like a minor example of that it's that from 10 gigs to a 5 gigahertz high-power device, showing a footprint of 400 to 500 meters in diameter to a distance of a few hundred meters, and that'll result in field strengths of some kilovolts per meter within the footprint, and it's able of making hundreds of volts to kilovolts on exposed wires or cables. And that hints at a lethal radii of hundreds of meters, depending on the weapon's performance and target's defenses. So to maximize the lethality, the first thing to do is to top out at the peak power and duration of the radius of the weapon. So for a certain bomb size, this is done by using the most powerful flux compression generator and the Vercator in an HPM bomb, which will obviously fit the size. And energy not emitted is wasted energy at the cost of lethality. Next is maximizing coupling efficiency to the target set. And a good way to deal with a complex and varied target is just use every chance of coupling available in that weapon's bandwidth. A low-frequency bomb built around an FCG will need a big antenna to supply the good power coupling to the surrounding environment of the weapon. And weapons made this way are inherently wideband, since most of the power made in it is below 1 megahertz, and the small antennas just aren't an option for that. One possibility is for a bomb getting close to its firing altitude to send out 5 linear antenna elements, and that's done by ejecting spools of cable which will unwind hundreds of meters in length. So 4 radial antennas, it'll form a virtual earth plane surrounding the bomb itself, while an axial element can create the power form of the FCG. So the selection of the element lengths would be needed to properly match the frequency and to make the proper field. A high power is needed to match the low impedance of FCG output. And that's because the higher impedance of the antenna, making sure the current doesn't pulse, because you can fry the cable early if it's not timed right. And there are other alternatives to that. One is to just guide the bomb close to the target itself and count on a near field made by the FCG winding, which is just a loop antenna with a small diameter related to the bandwidth. So coupling isn't the best, and the use of the bomb that is guided would let a more accurate hit be made. So an area worth looking into further in the sense of that is like damage or destroying magnetic tape libraries, since the fields near a flux generator are of the type, that's whatever frequency it'll damage the microwave tapes. I'm not sure the exact frequencies either. But the microwave bombs themselves have a wider range of coupling modes against a small wavelength, and it can be focused against targets with a compact antenna. And I've got another picture of it here of what the whole antenna Vercator assembly looks like. Yeah, so everyone can see that all right? Yeah, so that's it. Let's see, so where you see it coming through, on this side, there's the reflector, the axial vericator that I mentioned before, the antenna feed ports. All right, see the backfire reflector, the multifiliar, the whole helical assembly, and the polarized radiation. Let's see, there it is, and that's the wave itself emitted from it. All right, so targeting for it, it's easy to determine, because there's just so many things that are, that are able to be used, and I don't mean always in a military sense. If a government wanted to act against its people, cripple the infrastructure, take out all of their internet service, phones, electricity, everything. And the targets, and it's also good because it's geographically fixed. And so, it's going to make air attack the best way to do it. So the accuracy for it, it's programmed because of GPS, and it's camouflaged in the mobile targets that'll radiate openly. So relocatable and mobile air defenses, mobile communication nodes, naval vessels, and they're all examples of certain targets. When radiating, their positions can be tracked with suitable electronic support measures, ESM, I'll call them, and ELS, emitter locating systems that are carried either by the launch platform or remote surveillance platform. With the aforementioned surveillance platform, the target coordinates are constantly linked to the launch platform, and most of the targets like that move pretty slow, and they're not able to get out of the EMP's footprint in time. So hidden targets, mobile targets, which won't openly radiate, can be a problem, especially if regular means of targeting are being used. So a targeting solution to this is finding and tracking of unintentional emission, UE, I'll call it, and that's gained most attention in the sense of tempest surveillance of all things, where roaming emanations leaking from poorly shielded equipment can be spotted, and in many cases can be demodulated to get a useful piece of information out of it. And it's called Van Eck radiation. So if you're familiar with Van Eck freaking, so that you know what I'm talking about. And such missions like that can be they can be best kept down with proper controls, and there are control techniques. I'll show another transparency about that in a bit. So demodulating the whole UE, it's difficult to take care of that in targeting of EMP bombs because it doesn't present the problem. So targeting an emitter for an attack, it needs only to determine the type of emission, target type, and isolate its position. And that's because of the fact that the computer monitor emissions, peripherals, and any processing equipment, switch modes, internal combustion systems, duty cycle controllers, thyristor Triassic-based, heterodyne receivers, things like that. And they all have their own frequencies and modulations. And it just, it makes it that much easier. It's not just a block of frequencies they look at. Everyone can be picked out and dealt with. So I was like, during the Vietnam War, in fact, it was used when gunships went out at night and they were using direction finding receivers to find emissions from vehicle enemy ignition emissions. And once found, the vehicle would be attacked. So now UE happens at a pretty low level. And the use of that method for detection before any incidents can be difficult to use because it might be needed to actually fly over the target itself and start tumbling for frequencies. So the use of drones are going to be used more in that. Now, actually getting the bomb there, it's similar to a regular explosive warhead, and it's filled to a certain amount of space, and it has a given mass determined by whatever hardware they're using inside of it. And the existing deployments that are there now, well, I'm sure there's probably more that had this because the info I have, it's a couple of years old. But it involves fitting the warhead to a cruise missile's airframe, but the frame itself is going to restrict the weapon's weight to about 750 pounds, or 340 kilograms for our European friends. And some restrictions in fuel capacity could see the size increased. So a restriction of all uses is the need to carry a power supply given to the current to charge the capacitors that are used to prime the FCG before it actually goes off. So the payload will then be balanced between storage and the weapon itself. And the weapon, like a cruise missile, the size of the priming current source, as well as a battery, can impose a restriction on the weapon's ability. Because air-delivered bombs having a flight time of tens of seconds to minutes can be built to boost the launching aircraft power systems. And in such a design, the bomb's capacitor band can be powered up by the aircraft on its way to the target. And after release, a smaller onboard power supply can take over and keep the charge going at a certain level. So an EMP bomb delivered by regular aircraft, it'll offer a better ratio of total annihilation in some cases, because the mass of it can be committed to an EMP device installation itself. So if that's the case, a given technology for an EMP bomb of identical mass to an electromagnetic equipment or an electromagnetic equipped missile can be more lethal and can assume greater accuracy of delivery and technologically similar electromagnetic device design. So a missile with an electromagnetic warhead installation will make up the EMP device. An energy converter and an onboard storage unit, like a battery, are obviously needed. And as the weapon is charged, the battery is drained. So the electromagnetic device will be off by the missile's onboard fusing system, and it'll be connected to the navigation system in the cruise missile. And an anti-shipping missile, I shouldn't have used the term anti-shipping, but it's meant for any naval craft. The radar seeker and anything that's air-to-air missile is the proximity fusing system, and the ratio of payload mass to launch mass is anywhere between 15 to 30%. So an EMP bomb's warhead, that'll make up an electromagnetic device, an energy converter, and a bomb to charge the whole device after leaving the platform. The fusing could be furnished by a radar altimeter fuse to detonate the bomb in the air, barometric fuse, or in some cases even GPS-guided bombs, the system's navigation. The warhead ratio can be as high as 85%, with most of the good mass being occupied by the electromagnetic device and supporting hardware. So because of the large, potentially lethal radius of the device, it's, well, let me see here. Okay, I think I just killed a fly. In relation to an explosive device of a similar mass, standoff delivery would be better. This is an inherent characteristic of the weapons, like a cruise missile, but possibly the use of that device for guide bombs, anything against air-to-air missiles, it's going to dictate fire and forget guidance of the right variety to let the launching aircraft get a good distance of a few miles before detonation. So GPS guidance for weapons has meant good guidance for little cost, while the GPS weapons without a differential GPS add-on, it might not have dead-on accuracy, but they're accurate to within 40 feet. So in recent years, the Air Force has done a number of things with it. And the importance of that means that as a form of delivery for it, there's three benefits. The first being that the guide bomb can be let go from outside the effective radius, reducing risk to the aircraft. Second, the large standoff means that the aircraft can be well away from the effects of the bombs. And third, the bomb's autopilot can be programmed to form the terminal trajectory of the weapon, so the target can be engaged from a better angle. And the big advantage of using EMP bombs is that they can be delivered by any tactical aircraft with a NavAttack system that has GPS equipment. So if weapon ballistic properties are the same to a standard weapon, no software changes need to be made to the EMP bombs, and it's simple in comparison to weapons like ARM, anti-radiation munitions, and that's due to low-cost manufacture and support, and that it can be expected that there's going to be a greater number of these used in the future. So in that sense, it's worth being aware of the Air Force's possession of the JDAM-capable F-117A and the B-2A, and the ability to deliver the EMP bombs against high-profile targets. So, defensive measures. Yeah, so if any of you have seen the movie Enemy of the State, where they made a reference to copper shielding being inside the walls, that was a takeoff on this. Yeah, there it is. And so, when I'm done, if any of you want to come up and take a look at this, that's fine. So on the limitations of the weapons, it's determined by the usage, and it does restrict accuracy. But the weapon best used to destroy solid-state computers and the receivers. It'll cause little or no damage, such as anything that's Cold War, Russian military equipment, anything from when Germany was split in half, etc. So, and that points out limiting the radiation. It's difficult, to determine a kill assessment, because radiating targets like radar or communications equipment can continue to radiate after an attack, even after their data processing systems have been killed. So it means that some equipment may be able to still suffer an attack and continue working. On the flip side of that, any emitters that are shut down before an attack may not show damage right away. So, and I've got another transparency here for what this is. It's a strategic air attack model. So when one of these are delivered, man, that is shitty res. Anyway. Yeah, so you want to go for the leadership, the computer networks first, and it'll radio out machinery, the railing signals for railroads.
It'll be a cascading effect because once the leadership's taken out, everything else will just go right, pretty much, if not right away, eventually.
And ultimately, it'll go down to the field troops for their even just simple two-way radios. So. Now, I know Big Brother has been really toying with this, so you might want to take a note on this and look it up later. But there are a number of executive orders that were signed a while ago, and it was combined into Executive Order 11004. That's part of it, and that'll provide for the Housing Finance Authority to relocate communities and designate areas. So if, let's say, a government were to move against its people and wanted to make sure they were staying out of there, why not fry everything they own? And all of it was also combined into another executive order that Richard Nixon had signed. And, and even now, all of us are aware of the problems that are coming down the road. And this is one I just came across and wanted to point out because it does put the whole hacker community at risk because we stand to lose everything. So here's Sergey.
All right, I'm gonna say something first, and if we have time, Leo's gonna talk about HERF weaponry. But I decided to come right now because Leo's and Gonzo's material deals with anti-infrastructure weaponry. All of it, obviously, since it's not directed against personnel, it's not directly legal, though. If you destroy the life support systems, such as agriculture, transportation, power, and communications, things of that sort, eventually will lead to casualties. However, right now what I'm going to talk about is non-lethal anti-personnel technology, not just the kind that can be used during warfare, but also when policing. A lot of times police want to get their suspect without damaging him, without hurting him in any way or killing him, as may be the case in some unfortunate situations. Now, one of the most interesting devices that I've come across is a tetanus ray developed by a company called HSV Technologies. They have a website at hsvt.org in case anyone wants to check it out. I'll also give you the patent number later, but first I'd like to mention the predecessors of this technology, which are actually being also presently developed. They're being developed in parallel to this technology, and they're manifestations of taser technology. In case anyone does not know what that is, it involves just cranking up a high voltage current, low amperage current through a human body, which basically just stuns the human being or animal, as it's used on cattle in some cases. the Air Force and I believe the Army have developed vehicle-mounted tasers which could be used against mass groups or focused on an individual being, and they utilize two ultraviolet lasers to ionize the oxygen molecules in the air. It takes three photons to just basically, when you pulse a laser at oxygen, the oxygen atom emits, it loses an electron, thus becoming a positive ion, making the, just making a nice ionic channel for the electric current to go through. So there's two ultraviolet lasers which create a conductive circuit, one going from the taser, one coming back to the taser, which allows the operator of the device to actually just shoot out an electric current without the need of wires, which are used in an air taser, which either has a gunpowder charge or a compressed carbon dioxide charge to shoot out two electric prongs and thus stun the subject. This instead uses it's kind of like a sci-fi ray gun. It just shoots out two rays of ultraviolet radiation pointed at the target that ionizes the oxygen. Then it shoots. Then it uses the conductive paths to shoot the current through there, and basically it has a taser effect on the people. The new technology, the tetanization, is a variant of that. It uses modulated current at I don't know, I'm still not able to find a proper frequency, as I think that is also proprietary information. However, I'm working on it in my own little ways. It uses modulated current to simulate electrical impulses used by the nervous system to create a tetanizing effect. And for those who don't know, tetanization basically it's the stimulation of muscle tissue at a frequency which merges the individual muscle contractions into one single sustained contraction. So muscles, when they get electrical impulses, between the nerve impulses, they tend to relax. A tetanizing effect, it does not allow the muscle to relax. It just keeps the muscle clenched up. And with this ray, a person affected by this ray would not feel any pain if the ray is modulated properly. They would just freeze up, and when they were standing, if their body was balanced, they would not fall down. They would only fall down if it was used against them during running, if they're running or just off balance in any way. Now, some might wonder if, for example, this might be harmful to the eyes because it's an ultraviolet laser just shooting at you. However, it's not shot at such high amplitude so as to damage the retina, and damage to the skin is almost non-existent, since all it does is it ionizes the air. When it hits the skin, it's pretty much harmless. It's just like going to a tanning bed and lying there, but for a much briefer interval. There's also, the lasers themselves can be modulated depending on the range. So for maximum range, which can be 2 kilometers, you would use a frequency of you would use a wavelength of 298 nanometers. So that extends the range to up to 2 kilometers. The smallest range is when you're using the wavelength of 193 nanometers. The effective range is 100 meters. For those of you who have a pen or a pencil, I can give you the patent number, so you can go to the United States Patent Office website and just get the entire text and diagrams of the patent. The Patent Office website is www.uspto.gov/PATFT, and the patent number is.
Just repeat that again.
Oh, it's uspto.gov/PATFT, and the patent number is 5675103. It was issued out on October 7th, 1997, so this is relatively new technology. Yes, 5675103. It's pretty old. It's a 7-year-old patent. It's been actually applied for before that, but well, that's not really relevant in this case. I'm just going to make this brief. I have another device I want to talk about. It's not a device in and of itself as much as an effect of infrasound. And I'm not going to go into rather technical details, as infrasound is basically any noise that whose frequency is below that of 20 hertz. Though most people, when they say infrasound, they utilize things up to, for example, as high as maybe 100 hertz. Though scientifically that's not considered infrasound, I still merge it with a group. Infrasound is used naturally by animals, mainly mammals like whales and tigers and elephants, to stun and shock prey, or elephants, for example, use it as a defensive measure and also to communicate, since infrasound travels quite far and it tends to hug the ground. So it's good. It's very good for communications, and since it's very hard to stop. As we all know, if you have someone in a party blasting music above you, the first thing you hear is the bass. That tends to penetrate more than anything else. So the lower the sound, the better the penetration. There are lethal frequencies which at a certain decibel rate can kill, and those tend to be around the 7 hertz range, 3 to 7 hertz. If you do it though, however, if it's done for a short amount of time, it can be used as a non-lethal weapon. It will just make the subject, or the mark, rather sick. However, the negative effect to using these weapons is that you can't exactly focus it too well, and it tends to travel back onto the user. So the best way to utilize it is as a remote technology, which might be utilized by some military agencies. Does anyone here want to say anything? Or Lee, you want to
Well, I know Leo has some, he's got a couple things to follow up on.
Yeah, I'm basically finished. That's the two major anti-personnel
Okay.
non-lethal technologies, which are new, because there's other technologies which are more common and that we know of. Maze, there's foam that shoots out, which incapacitates the target because he's just all stuck together. But those have been more talked about. So thus I presented two technologies which are not in the open as much as they should be, since they're quite interesting. All right, and I'm going to invite Leo up here to speak.
No, actually, no, we got the nod, we're out of time. They
All
said, get out!
You're going to say
And,
something or no?
no, well, no, if there's any,
Yeah,
if there's any questions, just come on up.
Yes, you want to? Yeah, you can actually come up and give you the mic.
Well, everyone except for Gray, she's
Oh, there's a mic
dangerous.
on there. Pardon me. Could you get the mic on?
No, just going up to.
Can one of the three of you set up a website, maybe you've already got a website, where the three of you can put a whole bunch of URLs and stuff down?
All right.
Put a bunch
Well.
of you together, just pick one of you right now,
All
give us
yeah.
one of your
All right.
websites.
So for the people who are going to be listening to the recordings, the question is if we have a website where we can put all these things. Sure, Gonzo would like to answer that
my
question.
site. All right, you can visit my site. It's just a little bit of everything. Reprimandmag.com. REPRIMANDMAG.com.
Yeah, that's Reprimand Magazine.
And that's probably the best plug my site's ever gotten.
Yeah.
Yep, all right, so
Any
that's
other
it. Yeah, so,
questions?
no, well, thanks for showing up.
No? All right, thank you. You've been a great audience, and we're going to step off the stage now and make way for the simultaneous broadcast of the social engineering panel.
We have to get downstairs.
Oh, 7 minutes?